Here we are at part 3 of our graphing lecture. In this part, we will be going over slope, linear equations, and how to interpret curves. So first off, what is slope? Slope is a value that describes the steepness and the direction of a line. Basically, it tells you the change in y value versus the change in x value. So we represent that as rise over run. Rise being the change in the y value over or divided by run, the change in the x value. So a positive slope, meaning the rise over run fraction is a positive number. With a positive slope, the line goes up to the right. That's this blue line here. With a negative slope, when the rise over run is a negative number, the line goes down to the right, like this red line here. So like we said, rise is the change in the y value, and run is the change in the x value. Let's take a closer look at this. So if we have this line here, I am going to determine my slope by picking 2 points in which the line intersects a whole x value and a whole y value. So this point right here, you can see the red line goes right through the corner on the graph here. We have a whole x value of 1 and a y value of 12. The next point where you get a whole x and y value is right here at 2 on the x-axis and 9 on the y-axis. So to determine the slope, the rise over run, we're going to work between those 2 points. We're going to look at our rise first. So for the rise, we go down 1, 2, 3. That's our rise. -3 is our rise, and we go over 1 in the positive direction. So 1 is positive. So we end up over here with -3, our rise, over 1, our run. Now what's -3 divided by 1? It's just -3. So our slope for this line is -3. Now let's talk about linear equations. Some of you who have taken some algebra may be familiar with the equation y equals mx plus b. This kind of equation is the mathematical representation of a straight line, like the line that we have here. So let's break down this y equals mx plus b equation. Y is the variable represented by the y-axis, so in this case it's price. M represents the slope. X represents the variable on the x-axis, so the quantity in this case. And B is what we call the y-intercept, which is where the line, our red line, crosses the y-axis. So let's look at the equation for this particular line. All we're really going to worry about is the slope and the y-intercept, the m and the b. That's all we need to write the equation of this line. Don't worry about the y and the x for right now. So our slope, we already determined in some of the last slides that our rise over run is -3 over 1, which is equal to 3. So our slope, our m value, is -3. Now our y-intercept value, we can just see visually where our red line intersects the y-axis. We see that that happens at 15. So B, our y-intercept, is 15. So if we plug our slope and our y-intercept into the linear equation, we end up with y equals negative 3x plus 15. Now, what these equations allow us to do is to answer questions. Like, if I wanted to know how many bouquets I would sell if I charged $4, 4 is a y value, $4 is a y value, so I could plug 4 in here for y. And then I would solve algebraically for x to find out how many bouquets I would sell at $4. Now, we won't be going into the actual algebra in this video, but you can see that these equations are useful for answering questions like that. Now let's talk about curves. You often see curves in economic graphs. What does that mean? So with a curve, unlike with a line, like this red line, the slope of this red line is the same everywhere on the line. With a curve, the slope changes over the course of the curve. You can see it's very gradual up here, and then it gets steeper and steeper as you go down the curve. Now, what this means when you have a small slope like you do up here, it's a very gentle slope. That means that if you, so say we are selling our bouquets for $10, and we haven't sold any of them. No one wants to buy a bouquet at $10. But if we drop the price by just $1, or just one value, we're going to sell a lot more bouquets. We sell many more additional units for a small decrease in price. Further down here on the curve, we start to sell less additional units per increase in price, or sorry, per decrease in price. So we could have a large decrease in price, let's say from $4 to $1, and we're not even going to sell an entire additional bouquet. So this change in slope on the curve, knowing where the slope is can be useful for decision making. Where the slope is a certain value can be useful for decision making. We may have data that suggests that our business does the best when our sales curve has a certain slope. So on the point of the curve where the slope is a specific number. So let's say that we know it's best for our business if this curve, if we sell bouquets at the price where the curve has a slope of -3. So where do we find that on the curve? Well, we can take a straight line that has a slope of -3, and we can move that straight line tangent to the curve, tangent meaning just touching, and where that line just touches the curve, that is where the slope of the curve is -3. So we could see here, if we know that where the curve has a slope of -3, that's the best price to set our bouquets. We can see that's $5. So we can make a decision that our business will do best if we charge $5 for our bouquets. Let's do some practice in your notes. So go ahead and pause the video here and go over these questions, answer them in your notes, and in the next video, we will answer them together. But I do urge you to try this on your own first, and then we can fix any mistakes in the next video.